Welcome to the Python Data Engineer's Journey with Snowflake. I'm Manuela Wei. I'm a Senior Product Manager at Snowflake, responsible for data orchestration. And I'm joined by...
Hi, I'm Doris Lee, and I'm a Senior Product Manager at Snowflake, responsible for Snowpark.
Some of the problems we hear from customers regarding data engineering are siloed data and fragmented tooling. Often data is stored and processed in different environments. This is further exacerbated by fragmented tooling, especially when processing data in SQL or Python. A fragmented practice makes it difficult for teams to scale their data pipelines across various tools, which results in slower value derived from data and, even worse, gaps in data security and governance. Snowpark is a purpose-built for data engineering, ML, and application development to address the challenges with siloed data. Snowpark enables processing where the data is and optimizes data pipeline development and execution. Snowpark meets data practitioners where they're at by supporting their choice of programming languages and libraries while leveraging the strong data security and governance capabilities of the Snowflake platform. We also have Snowpark Container Services, which provides a fully managed runtime environment with your choice of CPU and GPU options to run your custom code in any language. Snowpark has been GA for a while. We're thrilled to share the momentum and success in using Snowpark. 50% of Snowflake customers are using Snowpark, running 100 million Snowpark workloads daily. Customers have been able to achieve a 4.x faster performance with Snowpark workloads and 35% cost savings by running on Snowpark versus managed Spark. In addition to the siloed data, we observe challenges with fragmented data engineering practices across the industry, with the use of a variety of tools and a lack of best practices. Snowpark solves for this with purpose-built products to make data engineering easier, more scalable, and accelerates data pipeline creation from ideation to production. Now that we've discussed the challenges with data engineering, let's look at how Snowpark accelerates the end-to-end process for developing Python data pipelines. We'll start with the authoring experience, where customers have options for authoring their Python data pipelines using VS Code, Streamlit. In this session, we're focusing on notebooks. Next, customers have a wealth of options for transforming their data, from Snowpark Pandas API to async stored procedures, and Snowpark supports local testing for rapid and iterative development. After testing, you're ready to productionalize and orchestrate your pipelines using tasks, which is Snowflake's native data orchestration capability. In this session, we'll be focused on serverless tasks with Python support and serverless tasks Flex for low-cost compute. Lastly, for continuous management and DevOps of your productionalized pipelines, we offer the Python API, Git integration, database change management, and Snowflake Trail. Now, Doris will share more details on the Snowpark capabilities enabling data practitioners to more easily author their Python data pipelines.
The first step in developing your Python data pipelines is to author and develop your code. And Snowflake offers a variety of authoring surfaces for data engineers, including worksheets, our VS Code extension, and the latest addition to this is our new Snowflake notebooks. So notebooks provide a familiar environment for data teams to seamlessly write code, develop and train models, and build models and data pipelines more efficiently, all in one place. It's this interactive environment for writing Python and SQL code, and it also allows you to develop and iterate on your data workflows and pipelines. Notebook simplifies and streamlines workflows for our Snowflake builders, and it's integrated nicely with Snowpark ML, Streamlit, Cortex, and Iceberg tables. Notebooks also work with Git integration for version control and an automated scheduler for scaling data pipeline development. For data engineering, one of the next steps that you need to do is to get your data into Snowflake. And that can involve ingesting data from many sources outside of Snowflake. For example, from your own line of business application, or let's say Azure SQL. Many customers have endpoints, services, or resources which aren't exposed on the internet today for various compliance reasons or based on the nature of the data. They would want to connect to those resources without traversing the internet. And so, to make this happen, we've recently announced a public preview of external access private connectivity. This means that you can now make connections from Snowflake to external resources via a private link. So let's say I have some data source in Azure. You can connect to this source and also ingest that data into Snowflake. Now, once you have your data ingested into Snowflake, it's time to transform that data. And so we've recently announced the general availability of Pandas on Snowflake, which lets you work with your familiar Pandas API for flexible data transformation, with the compute pushed down and running scalably and securely directly in Snowflake. So what are some of the benefits in using Pandas on Snowflake? So it's well known that Pandas doesn't work well on large data sets. It's single-threaded, so things can get really slow as soon as you're operating on data at scale. What's even worse is that when you're working on data that doesn't fit into your memory, the moment you exceed that memory limit, you start to run into these out-of-memory issues. So with Pandas on Snowflake, you can continue to work in Python by writing Pandas code. What we do is we take your code and automatically compile it to run on Snowflake so that you get the benefit of distributed pandas at scale without having to worry about managing or tuning your compute infrastructure so that you can seamlessly take your pandas code from prototype to production. Second, Pandas operates on your data in memory, so it requires that you pull your data out of Snowflake, which can lead to security concerns when your data scientists need to pull out sensitive data onto their local machines or laptop to be able to do their analysis with Pandas. And so with Pandas on Snowflake, you can generate the underlying SQL queries that are executed directly in Snowflake so that your data never have to leave the warehouse. Organizations then inherit the security and governance backed by Snowflake. One of the other things that we also hear a lot from customers is that they often need to rewrite their Pandas code into a big data framework such as Spark or Snowpark in order for their pipelines to work on larger scale data in production. Now, this involves a substantial amount of developer time and hand optimization and rewriting. With the introduction of Pandas on Snowflake, there's no need to rewrite your Pandas code. Developers can leverage their familiar Pandas API, freeing them up to focus on optimizing for business outcomes and putting more pipelines in production. So here's a glimpse of how we're doing this underneath the hood. So the Pandas on Snowflake capability delivered through what we call the Snowpark Pandas API. And the Snowpark Pandas API, what it does is that it takes the query, the Pandas query that the user have written, in this case, a pd.concat, which combines two data frames horizontally. It essentially translates that query and compiles it down to SQL so that it can run on the underlying Snowflake engine. And so this is how we're able to achieve the massive scalability that you saw a couple slides earlier, because all of the compute is happening directly on Snowflake, and there's no data that needs to be pulled into the client side. And so this is a very scalable approach. Now, we also have a line of exciting updates for you with Snowpark, which we encourage you to check out more in each of these sections. And next, Manuela will be sharing how Snowflake supports two other critical pieces in our Python data engineering workflow, namely orchestration and DevOps.
Thank you, Doris. Now that you've authored your Python data pipeline to ingest and transform your data, we'll focus on the next step of orchestrating your data pipeline. With serverless tasks, customers have options for natively orchestrating data pipelines in Snowflake. One option is to run your pipeline on your user-managed virtual warehouses. However, it can be challenging to select the right size of compute for efficiently running your pipeline on Snowflake. Therefore, we recommend using serverless tasks, which can easily automate your data pipeline on Snowflake-managed warehouses and remove the burden from you on selecting the right size compute to balance price performance of your data pipelines and automatically scale to handle a variety of workloads. With on-prem or cloud orchestration products, The burden is on you to manage and fine-tune the compute required to successfully run your pipelines without resource wastage. With serverless tasks, you can focus on building your business use case while confidently running on Snowflake managed compute, which is optimized for price and performance based on your workload profile, thereby reducing wastage and lowering the total cost of ownership. We're pleased to announce Serverless Task Flex, now in private preview, as the most cost-efficient way to run your user-defined SQL, Python, Java, Scala functions and stored procedures, while benefiting from the ease of use of running on Snowflake managed compute. Comparatively, pipelines running on Serverless Task Flex cost 22% less than running on serverless tasks. You can create a Serverless Task Flex by simply specifying to run in a flexible scheduling mode and a target completion interval. Also available now in public preview is Serverless Task Python and JVM, where you're able to automate execution of user-defined Python, Java, Scala functions on serverless tasks by calling existing UDF or by specifying your code directly in the serverless task definition. Today's data-driven world requires an agile approach. Modern data teams are constantly under pressure to deliver innovative solutions faster than ever before. We're excited to provide all Snowflake customers with the core building blocks needed to streamline development workflows, aligned with the DevOps best practices and paving a seamless path to production. Data pipeline developers need better products and processes to support this agile, continuous delivery cycle, from building code to automated deployment to monitoring and operations. As a data engineer, this streamlined workflow enables me to focus on building and coding my data pipelines without worrying about complex configurations or manual deployments. Once my code is written, any changes to the underlying database objects will be automatically updated thanks to database change management. This ensures consistency and reduces the risk of errors. Pushing code updates to my remote Git repository triggers a CI/CD pipeline to automate all the build and test steps. And I can automate the deployment process for Snowflake objects using the command line interface integrated with Git. This streamlined workflow empowers me to focus on what matters most, which is building high-quality data pipelines while saving time and minimizing manual effort. Now, let's take a closer look at the exciting new features designed to make delivering data pipelines much easier. The Python API in GA enables you to leverage the power and flexibility of Python when building and managing your data pipelines. Database change management enables you to view, create, and alter database objects and reduces the need for manual scripting. Lastly, the Snowflake CLI is specifically designed for managing and automatically deploying Snowflake objects. With these features, we're committed to providing you with a more efficient and streamlined data engineering workflow. Now let's take a look at the Snowflake Python API, which is a powerful tool designed to simplify and unify your data engineering workflows. The Python API delivers the following benefits: a unified Python experience, provides a simplified, consistent interface across data engineering, Snowpark, ML, and application development, thereby streamlining your development process. Schedule and manage Snowflake tasks directly within your Python code, which allows for building complex workflows with ease, all with a familiar Python environment. You can leverage the Python API to effortlessly interact with Snowpark container services. This opens up a world of possibilities for utilizing Python libraries and frameworks for your data processing needs. And lastly, you can manage your tables, schemas, databases, and warehouses declaratively using Python. The Snowflake Python API represents a significant leap forward in data engineering efficiency by providing a unified interface and the familiar Python syntax. This allows you to focus on building innovative solutions. The last mile in DevOps requires timely visibility of your pipeline executions in order for you to take quick actions on issues. Snowflake Trail offers comprehensive capabilities for monitoring, debugging, alerting using OpenTelemetry the open source standard for observability. While providing rich observability directly in Snowflake, we also seamlessly integrate with industry standard monitoring tools such as Grafana, Datadog, PagerDuty, and Slack. Now Doris will show you an exciting demo of the latest and greatest features in action.
Thanks, Manuela. We'll first take a look at the overview of what we'll be demoing today. So we'll take a look at how you can build a Python data pipeline by putting together some of the components of what we discussed earlier in action. So starting with data ingestion, we can use external access over private link to access data from Azure SQL, and we ingest that table into Snowflake. Now for our demo, we'll be focusing on the portion where we're actually developing our data pipeline in a Snowflake notebook. So for data transformation, we'll be using Pandas on Snowflake to process and transform our data. And this pipeline will save the results to a Snowflake table. We'll then show you how you can use the Python API to create a serverless task and orchestrate this pipeline. And then this entire notebook is connected to Git so that you can version control your code through Git integration. And with that, I'm going to switch to sharing my demo. What you're seeing here is Snowflake notebooks. So with Snowflake notebooks, I can create Python, SQL, or Markdown cells, as you could see here. And in this example here, I'll be using the Pandas on Snowflake feature to be able to build a data transformation pipeline and then orchestrate it with a serverless task. So first, I'm going to import some of my commonly used library. Again, Snowpark Pandas, the Snowpark Pandas API can be imported through these two lines of code. And then what we're also doing here is we're creating a Snowpark session. And then this is the name to the database that I'll be working with. So in this case, I'll be working with the TPCH dataset. And then I can use the command pd.read_snowflake to read the line items table that I have. And then I'm going to only keep these 7 columns here. So these are the columns that I want to filter to. And then finally, this result is stored in line item _df. And then once I have this Snowpark Pandas data frame, I can do df.head to take a look at the first 5 rows of the data. I can also use Streamlit to print out what this looks like. I can also do things like df.info to get a better overview of what my data looks like. Could also do df.shape, and we can see that there's around 6 million rows in this data set and around 7 columns. Now, I'm going to take a look at this attribute called return flag. And the return flag attribute tells me whether an item has been returned or delivered. And so I can call value counts on this column to take a look at what are the different values that the return flag can take. So in this case, N, R, and A, and the count of each of these values. So once I have this overall statistics, let's say that I want to filter out all the rows where return flag does not equal to A. So I can do that by running this pandas filtering command. So you can see that before filtering, I have around 6 million rows, which is the entire data set. And after filtering, I have around 4.5 million rows. And this is the resulting data frame. And one of the things I want to note here is that, as you could see, all of the syntax of what I'm doing here looks exactly like Pandas. Like the APIs and the look and feel is exactly the same. For example, here I can do a multiplication across the column, and you can see the new column being created. All of this is exactly the same as the Pandas API. But again, the compute is actually getting pushed down to Snowflake so that this data is not being processed in memory. The actual computation is happening on the Snowflake side. Now we can also do aggregations and group bys and things like that. So in this case, I want to do a group by on these two columns, and then these are the aggregation I want to do on quantity and discount amount. One of the things I like about pandas is the ability to kind of pivot and reshape the your table. And so in this case, I'm going to use a pivot table. I'm also going to kind of reset the index, and here we can take a look at what the resulting pivot table looks like. So these are the kind of the index column that I specified. So L order key is the index column, and then the values are specified here. Now, so far I've been working on the line items table, but I want to combine this with the orders information. So again, I can use pd.read_snowflake to read in the orders table. One of the things to know here is that when we do the pd.read_snowflake, we're actually not pulling the data into memory in order to process this. What we're actually doing is just, creating a connection and establishing a connection to this table, and then we can start to operate on our data frame with the variable, in this case the order table. I'm going to drop a couple columns and then print out what this order table looks like. Now, one of the things you might note is that all of the columns in this table has O underscore at the beginning. That tells you that this is from the orders table. You can see that here I'm doing a join across the orders and the line items pivoted table. And once I've been able to run this, you can see that this is the combined data frame, which has both the columns from the order table as well as the other columns from the line items table. So I'm going to go through these additional transformations really quickly because it's kind of boring. It looks exactly like pandas. It's the same sort of transformation, group bys, and so on. But you can see just the flexibility of being able to use the pandas API, but operating on much larger data sets. Now, the final thing I want to show here is I'm saving the resulting data frame as a table called customer profile. And then what we can do is we can run a SQL query and take a look at the customer profile table that has been saved. Now, the last step that we can do here is we can visualize the data distribution by using Matplotlib and Seaborn to take a look at the distribution of these different values. Now, once I have my data pipeline, data transformation pipeline that's built, I want to schedule it with a serverless task. And the way that I can do that is I can use the Python API to create a serverless task. And so the Python API, what I first need to do is I want to take all the data transformation code that I had from earlier, put it into a Python function. So this is all the same data transformation code that I have earlier. And then finally in this toSnowflake command, I'm just using a time-stamped customer profile sort of naming so that we can recognize that this is the table that is being saved. And then I want to create a stage and then register this function as a stored procedure. And then once I have that stored procedure registered, I can call the stored procedure using the SQL. But we're not going to call the stored procedure manually. What we're going to do instead is we're going to create a task and call this stored procedure. And you can see that this task is scheduled to run once every minute. So I'm going to go ahead and just run this and then resume the task because by default, all new tasks that are created are in a suspended state. So we just need to resume to get this task to run. So now if I go back to this line where I'm looking at the task details, I should be able to see that this is a task that is scheduled once a minute and it's started to run. Now, if I take a look at the task history, I should be able to see also that this task has been running. I can also go into the task details page on Snowsite um, to take a look at the status of this task. So again, this is the same task that we created on the notebook with the Python API. You can take a look at the graph as well as the run history, kind of the histories of these runs. And then we're going to give this some time to run. So hopefully the first run is now executing at this point. So you can see that, again, this is a task that runs once every minute. And then once it's completed, if you remember from earlier in the store procedure, we've saved this this table as with a timestamp, right? So it's called customer profile underscore timestamp. So ideally, if we go back here, take a look at if our task is completed. Still running at this point. So you could see that if we skip ahead for a couple of minutes, one of our runs have now completed. So this is the run that have succeeded. It, it took some time, and then we'll see that the next query it has been scheduled. Again, this is once every minute, and then if we go into this SQL query and take a look at the tables, you'll see that this has written a new table with the timestamp that is saved. So now I'm going to hand it back to Manuela to finish the rest of the slides.
Thank you, Doris, for sharing that powerful demo showing the capabilities in Snowflake to easily and confidently build a Python data pipeline. We saw first using notebooks to author your data pipeline, develop and train models all in one place, using pandas on Snowflake to easily work with the pandas API you're familiar with for flexible data transformation while scaling and securely running in Snowflake. By using tasks, we reduce the burden on customers by natively orchestrating your Python data pipeline using serverless tasks. And lastly, we use the Agile DevOps capabilities to easily and continuously deliver your Python data pipeline. While we focused on just a few capabilities for easily and efficiently building Python data pipelines, this slide showcases the variety of options available to you to address your specific use case requirements. And at the recent Snowflake Summit, we had many customers presenting their stories on how they achieved cost savings and performance improvements with Snowpark. Thank you so much for watching this session.
Want to level up your Snowflake skills? Look no further. With our North Star Builder Education program, we've made it easy to upskill and increase your exposure to Snowflake. New to the AI Data Cloud? Start with our Introduction to Snowflake Builders course. Already have the basics? Pick one of the 3 learning paths: data engineering, Gen AI and ML, or application development. Through a series of self-paced online courses and in-person workshops, you'll gain a fundamental map of what's possible in Snowflake, while receiving tactical how-tos on topics such as building an end-to-end data engineering pipeline. Plus, show off your progress with a variety of badges representing different skills and achievements. Enroll today at Coursera and stay tuned to see when we'll be in your city next for live in-person training events.